Hello there. Today we'll look at zeros of a polynomial. What do we really use, or how does it help us? And why do we need to find zeros of the polynomial? Well, as you know, if we have a polynomial g of x is equal to axn plus a n minus 1 x to the n minus 1 and so forth, we know that this polynomial n, which is called the degree, also tells us that we will have at most n zeros. So n will tell us also at most n zeros of the polynomial. And keep in mind, when we talk about zeros, we're looking for solutions. Okay? In addition, linear factorization tells us that n also tells us something about the number of factors we have. Okay? If f of x is a polynomial of degree n, where n is greater than 0, then f has precisely n linear factors. So what does that really tell us? If we look at an example, if we have g of x is equal to x squared plus 7x plus 12, and we factor this, notice that n is 2, so this tells me that the degree is 2, will have at most two zeros or two solution, but will have two factors. So g of x here is equal to x plus 3 times x plus 4. So these are my two factors. And if we take it a step further, to find the zeros, we take g of x equal to 0. So x plus 3 times x plus 4 is equal to 0. X plus 3 is equal to 0, or x plus 4 is equal to 0. So x is equal to negative 3, or x is equal to negative 4. So these are my solutions, also known as the zeros. Okay? Meaning that at x equal negative 3, this graph, if we look at the graph of g of x, that graph will cross or touch the x-axis at x equals negative 3 and x equals negative 4, hence the zeros of the polynomial. Okay? So what's the whole idea of finding the zeros? Well, if I give you a cubic equation, okay, if you're given a cubic equation, let's say the degree is 3, it is not very likely that you can solve a polynomial of degree 3. So, for example, if I have h of x is equal to, let's think of this as x cubed plus 7x squared plus 12x. Well, if you think about it, it's not quadratic, so you can't use the quadratic formula. But if there is a way I can rewrite this polynomial where I know one of the factors, and I could write it as a product of polynomials, factoring, where one of the factors is a quadratic, I'll be able to solve this. Hence, notice that we have a greatest common factor of x. So if you take out x, we have x squared plus 7x plus 12. Now this is quadratic, so you can solve this. Solving a quadratic, we can either solve by factoring, quadratic formula, completing the square, and so on. But if it's a prime polynomial, then most folks out there use quadratic formula. Okay, or completing the square will also work. So the goal is to take any given polynomial and to find the zeros, or first find the factors of the polynomial. And once we have the factors of the polynomial, we are now able to find the zeros. Well, and that's why the fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is greater than 0, then f has at least one 0 in the complex number system. So if n, in the last section we looked at complex numbers, if n is greater than 0, we know we have at least one factors in the complex number system. Okay? So we'll look at how do we solve these, how do we get there? Well, here we had a GCF of x. What happens if there is no GCF? Okay? Well, there is a theory out there, or a theorem that says, or a little test that we call the rational zero test. The rational zero test. Yeah? So what is the rational zero test? Well, if we have a polynomial once again where we have ax to the n all the way up to the constant term a0, so the rational test, the rational zero test, we say generally it's p over q. Okay? Or the rational zeros, I should say, the rational zeros is p over q, where p represents the factors of the constant term. And q are the factors of the leading coefficient. So that's what our rational zero test is. And now keep in mind, it's a rational zero. So we are looking for, or really, ways to find zeros. At least the rational zeros. What does that mean? Well, if we have a polynomial, g of x is equal to, let's look at one we have, x cubed plus x plus 1. X cubed plus x plus 1. So in this example, if we use the rational zero test, p is equivalent to 1 and q is also 1. So here is my p and the q will be here. That's my q. Sorry. This is my q. And here's my p. Okay, p is equal to 1 and q happens to be 1 in this case. Factors of the constant term, here is my constant. Well, what are factors of 1? Well, the factors of 1 is plus or minus 1. Factors of 1 happens to be plus or minus 1. So if you simplify this, right, what does it really tell us? It means that we have a positive 1 over a positive 1. Or we have a positive 1 over a negative 1. Or we have a negative 1 over a positive 1. Or we have a negative 1 over a negative 1. Those are all the scenarios of plus or minus. Well, this will produce 1. This will produce negative 1. This will produce negative 1. And this will produce positive 1. Or 1. So the only two of them we have is really 1 and negative 1. Those are two possible rational zeros. Okay? So that's what the idea behind rational zeros, and you will see how that helps, because if one of these is the rational zero, then I know what the factor is. And if I know what one factor is, then that factor times some quadratic when multiplied would be equal to this. So how do we know if 1 is a factor? Well, we saw in synthetic division, we also have the option, well, what is g of positive 1? If g of positive 1 is equal to 0, then we know that 1 is a 0. Well, let's try that. So we have 1 cubed plus 1 plus 1. Well, this becomes 1 plus 1 plus 1, which is equal to 3. So 1 doesn't seem to be a 0. What happens if we try what is g of negative 1? Well, this becomes negative 1 cubed plus a negative 1 plus 1, which becomes negative 1 minus 1 plus 1, which is equal to negative 2 plus 1, negative 1. So what does that tell me? What does that tell me? Well, it's telling me that this polynomial g of x does have a 0, but it's not a rational number. It's an irrational number. Okay? Definitely there is some 0, because we know from the endpoint behavior, this is a cubic. So if we look at the endpoint behavior, it is dropping on the left, rising on the right. So it must cross the x-axis. So there is at least one 0 there. So where is the 0? Okay, let's take a minute and try to see if we can come up with any hints in that.